In previous lecture, we learned how to calculate surface area using double integral and mass of a plane body or plane lamina. In this lecture, we will learn the volume integral and thereby how to calculate the mass of a body. So let us take an example. The first example that we are taking is find the volume bounded by the coordinate planes, plane x is equal to 1, surface y is equal to x square, and the surface z is equal to x plus y in the first octant. The question is typical. So the very first thing that we must understand is how is the shape and how can you draw the shape. So first you mark that coordinate planes. So if you draw the coordinate planes something like this, x axis, z axis and y axis. So this is xz plane, this is yz plane, and this is xy plane. So these are our planes. So the body that question describes is first bounded by these planes, and in first octant, so x and y and z all are non-negative. X greater than 0, y greater than 0, and z greater than 0. So the first thing you should mark that x greater than equal to 0, y greater than equal to 0, and z greater than equal to 0. So we have almost obtained the lower limit for all the variables. Now explore the other possibilities. Y is equal to x square is a surface, and there is another plane x is equal to 1. So x is equal to 1 plane means x, the value of x is constant and y and z are varying. So that plane is just a plane parallel to yz plane, this this plane. So this plane is x is equal to 1 plane. The plane is x is equal to 1. Now the shape is bounded by these ones. So now there is a surface y is equal to x square. So you know that y is equal to x square will be something like this. And because we are drawing in the first octant only, so leave that in the next one. So this is the shape. Now this is the surface. This surface raise this surface infinitely up and down. So this will be this surface. This is y is equal to x square. And finally, z is equal to x plus y. So realize that if y is equal to 0 means on the x-axis, so z is equal to x. So on the x-axis, z is equal to x will be a line of the form this. Z is equal to x. And on the y-axis, x is 0. So on the y-axis, z is equal to y. And again, there will be a line of the form this. Z is equal to y. Actually, 3D shapes are not easy to understand. And at this surface, y is equal to x square, the shape of z will be z is equal to actually x plus y means x plus x square. So sum of the distances of x and the value of obtained y parabola. So something like this. So it is not clearly visible to you, and I am not supposing that you will understand this figure hereby. So I have already drawn this one. So you could understand the limit. So limit of x varies from x is equal to, in the first option x is greater than equal to 0. So x start from 0 and x is equal to 1 plane has bounded. So value of x varies from 0 to 1. One limit that we have obtained. Again, just consider, just focus on the xy plane. So on the xy plane, this is y, this is x. So y is equal to x square, this is the curve. So value of y, just focus that we have learned in the area and surface integrals. So we can take a strip of this type. So value of y will be obtained from lower and upper curves in the area. So at the lower point means at x-axis y is equal to 0, and the at upper curve y is equal to x square. So limit of y varies from 0 to x square. Again, we have obtained two limits. Now third limit. So for third limit, I am presenting the 3D figure to you, and I hope you will understand that. This is the figure that these planes, this surface y is equal to x square and z is equal to x plus y will actually. So this you can see this one. This is from the back. So back view are rear view, and these two are the front view, lateral and front view. So this is the shape. So at any point this z is equal to x plus y. So limit of z, when you can see that when x is equal to 0 and y is equal to 0, then z will be 0, and x and y do not assume negative values. We have already discussed that x is greater than equal to 0, y is greater than equal to 0, and z is also greater than equal to 0. So initial value of z will start from 0. So lower limit of z is 0, and upper limit at any point xy on the coordinate plane, corresponding value of z is x plus y on this plane. This plane. So value, upper value means upper limit of z is x plus y. So finally we have got that x varies from 0 to 1, y varies from 0 to x square, and z varies from 0 to x plus y. So now just uh, write the volume integral. So we have already discussed in double and triple integral lecture. So volume is equal to triple integral dx, dy, dz, and put the limits. So x has the limit 0 to 1, y has the limit 0 to x square, and z has the limit 0 to x plus y. So z contains two variables, so it will be integrated first. So integrate it. So we will get, integrating z first, we will get 0 to 1, 0 to x square, and then z integrated, just dz gives z. So this is 0 to x plus y, and dx dy is now with us. So this is 0 to 1, 0 to x square, and put the limit on z. So this is x plus y dx dy. Now we have just the area integral. So y will be integrated first because y has the variable limit. So 0 to 1 xy plus half y square, and the limit is 0 to x square dx. Again this is 0 to 1 xy, put the limit. So you will get y will be replaced by x square, and lower limit will be uniformly 0. So this is x cube plus 1 by 3 x to the power 4 dx. And now I assume that you will integrate this. First term gives x to the power 4 by 4, and second term gives x to the power 5 by 15. So overall you will get the answer 7 by 20. So this is the volume of the shape bounded by the planes and surfaces we discussed in the question, this question. Now let us calculate the mass of the body discussed in the previous example. So we are taking, find the mass of the body bounded by the shape given in the previous example, if the density at a point xyz is given by rho is equal to x minus 2y plus z. So what you have to do is, if we have an elementary volume elementary volume dv is equal to dx, dy and dz. So its mass of elementary volume is rho dv, means rho dx, dy and dz. So what we should do is integrate this elementary mass over the entire volume. So mass of the body is equal to triple integral over the volume rho dx, dy and dz. And we already know that in the earlier example, limit of x was 0 to 1, limit of y was 0 to x square, and limit of z was 0 to x plus y. So we just need to put these limits on the triple integral. So mass is equal to triple integral 0 to 1 and 0 to x square and 0 to x plus y rho dx, dy, dz. Now we will put the value of rho in this integral. So mass is equal to this 0 to 1 and this 0 to x square and this 0 to x plus y, x minus 2y plus z dx, dy, dz. So you can integrate now term by term. So there is an easier way: integrate the one integral at one time and taking it extracting it separately, means separately integrate one integral. So we know that first we will integrate z integral, because z has variable limit in two variable section y. So let I1 is equal to 0 to x plus y, x minus 2y plus z dz. So if we integrate this, you can do it easily. So x minus 2y into z plus half z square, and the limit is 0 to x plus y. So just put the limit so that we have x minus 2y, x plus y plus half x plus y whole square, and just simplify it. So it comes out to be 3 by 2 x square minus y square. I have simplified it. So I hope you will simplify, and this is a homework for you to simplify the expression. So I1 is this. Now just put I1 in place of this integral. So we have mass is equal to, now we have mass is equal to 0 to 1, 0 to x square I1 dx dy. So what we obtained is mass is equal to 0 to, and r again, okay, so 0 to 1, 0 to x square I1 dx dy. So again simplify, take integral of the one in inner one. So again it's separately, if you consider it separately, it will be easier to write. So let I2 is equal to 0 to x square I1 dy. Why dy? Because y has variable limit x square, and write this. So this is 0 to x square, and I1 was 3 by 2 x square minus y square dy. So this is here to integrate 3 by 2, and this is x square y minus 1 by 3 y cube, limit is 0 to x square. So we get 3 by 2, just put the limits and you will get 3 by 2 x to the power 4 from first term. So x to the power 4 minus 1 by 3 x to the power 6 from the next term. So again I2 has been evaluated. So now you can write it as 0 to 1 I2 dx. So that the I2 stands for this integral. Now what is our mass? Mass is equal to 0 to 1 I2 dx. So we have sequentially evaluated one integral at a time, and it is easier to write. Otherwise you have to write each integral symbol in each line. So this is equal to 0 to 1 3 by 2 x to the power 4 minus 1 by 3 x to the power 6 dx, and what this comes out to be 3 by 2 x to the power 5 by 5 minus 1 by 21 x to the power 7, and limit is 0 to 1. So just put the limits. So lower limit is 0, upper limit is 1. So 1 by 5 minus 1. So you can calculate it, and the answer comes to be 8 by 35. So this is the mass bounded by the shape that we discussed in the first example. Take another example. So let us take this one. Find the volume of a prism bounded by the coordinate planes, and the plane x by a plus y by b plus z by c is equal to 1. So very first you should realize this plane, what this is. So if you draw the axis, this 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 is suppose x-axis, this is y-axis, this is z-axis. When you put y and z is equal to 0, means x, the plane intersect x-axis at some point x is equal to a, and it intersect y-axis at some point y is equal to b, and x-axis at some point z is equal to c. So this is the shape, and this inclined plane is given by the equation. This inclined plane is given by the equation x by a y by b z by c is equal to 1, and the coordinate plane, this is the coordinate plane, this is the coordinate planes, means xz plane, yz plane, and xy plane. So this is the prism, has four faces, one plane face on xy plane, one face on xz plane, one face on yz plane, and one inclined face that you can see by the triangle ABC. So I have also drawn this in the 3D figure. So this is the shape that I have described here. So this is the shape that I described. So this, suppose this is some point A, and this is x-axis, this is y-axis, this is z-axis. So you can take C here, B here. So this is the plane, and as the coordinate point, this is A comma 0 comma 0. This is 0 comma 0 comma C, and this is 0 comma B comma 0. These are the points, and this is the plane. So the plane looks like, and now just focus to obtain the limits. So very first take the limit of x. So limit of x, to find the limits of x and y, just consider the uh, plane wall of the prism on the xy plane. So let this be the x-axis and this be the y-axis. So you know on the xy plane z will be 0. So the equation will be x by a plus y by b is equal to 1. So you already know this is the a point on x-axis means a comma 0, and this is b point on y-axis means 0 comma b. This is the equation of line. This is x-axis, this is x-axis, this is y-axis. So and the origin, this is origin, and in 3D this is 0 0 0. So value of x varies from 0 to a. So very first that you should find out that 0 less than equal to x less than equal to a. This is the limit of x. And for limit of y, we have discussed a lot in the previous lecture and earlier lectures. Y varies from 0 to this line. So 0 to, from the above line, y is equal to b times 1 minus x by a. This is the line. So we have obtained the limits of x and y, and for the limit of z, this is the plane, this plane, this triangular plane that I already just discussed few minutes earlier in the same example. So this is the plane and the triangular shape you can see in the 3D. If you are unable to understand this 3D, take this 3D. So this is the triangle, and at each point of this triangle, z is given by this equation. This equation. So z can be taken as, when and on the xy plane, what is value of z? Xy plane z is 0. So value of z varies from 0 to on this plane. So at this plane means minimum value of z is 0, and at each coordinate point on xy plane, corresponding height of z is c times 1 minus x by a minus y by b. So on this plane, value of z is given by this. So we have obtained all the limits. So finally we have 0 less than equal to x less than equal to a, and 0 less than equal to y less than equal to b times 1 minus x by a, and 0 less than equal to z less than equal to c times 1 minus x by a minus y by b. This is how we find the limits, and once we obtain the limits of the figure, limit of this shape, 3D shape, we have just to integrate. So now what will be the volume? Volume is triple integral over this bounded volume dx, dy, dz. What remains is that just put the limits of these volume. So v is equal to x varies from 0 to a, x varies from 0 to a, and y varies from 0 to b times 1 minus x by a, and z varies from 0 to c times 1 minus x by a minus y by b, and dx, dy, dz. So very first we will integrate z integral. It has double variables x and y. So again we can write it 0 to a, 0 to b 1 minus x by a, I1 dx dy. Then what is I1? I1 is 0 to c times 1 minus x by a minus y by b dz, and this is just c into 1 minus x by a, this x by a, and minus y by b. So this is the value of I1. Now put the value of I1. So v becomes 0 to a, 0 to b times 1 minus x by a, I1 dx dy, and again we take it 0 to a, I2 dx. What is I2? I2 is 0 to b times 1 minus x by a, I1 dx dy. This I2 is I1 dy, and what is this? 0 to b times 1 minus x by a, c times 1 minus x by a minus y by b dy. This is our I2 integral. Means this one. First, this integral is I1, this integral is I2, and finally we will put the values of, we have already put value of I1, and we will now evaluate I2, then put its value. So what is the value of I2? I2 becomes I2 is equal to 0 to b times 1 minus x by a, c times 1 minus x by a minus y by b dy. So this is c times 1 minus x by a y minus 1 by b y square by 2, and the limits are 0 to b times 1 minus x by a. So just put the limits. So this becomes c times 1 minus x by a into b times into b times 1 minus x by a minus 1 by 2b b square 1 minus x by a whole square. So just simplify it and you will get 1 by 2 bc 1 minus x by a whole square. Now this is I2, and finally put volume v is equal to 0 to a I2 dx, so that we have 1 by 2 bc 0 to a 1 minus x by a whole square dx. Though I hope you can integrate it very easily, I am integrating. So this 1 by 2 bc, then 1 minus x by a to the power 3 by 3 into minus 1 by a, and the limit is 0 to a. So now you can put the limit and very easily it will come out to be 1 by 6 ABC. So this is the volume of the prism indicated in the question. And finally, let us compute if the prism discussed in the previous example is a solid prism, then we may be interested to compute its mass. So this question says in example 3, means previous example, take A is equal to B is equal to C is equal to 1 and find the mass of the solid prism if the density at a point is given as the sum of squared distances of the point from the axis. So first remember that if A is equal to B is equal to C, we will get this x-axis, y-axis, z-axis, and the plane will cut same distance on all of the three axes. So this and this was our prism. So now the coordinate will be 1 0 0 0 1 0 and 0 0 1. So in previous example, because we are computing the mass of the same prism that we consider in the previous example, just by taking ABC is equal to 1. So we see that x was between 0 to a. So this is now 0 to 1. Then y was varying between 0 to 1 minus x by a. So a is 1. So sorry, b times, this was b times 1 by x minus a. Let us write me clearly again. Y was varying between, so just back the video few minutes earlier and see that y was varying between b times 1 minus x by a. So this implies, because b and a are 1, so 0 less than y less than 1 minus x, and z was varying between 3 times 1 minus x by a minus y by b. Again a b are 1, so this means 0 less than z less than equal to 1 minus x minus y. So we have these limits, and just we have already in example 2 we have found the mass. So mass of the prism is, and also we need to calculate the formula for density. So first, mass of the prism is volume integral rho dx dy dz. So we need two things here. One is the limit on this volume. So we have already taken this limit x from 0 to 1, y and z. These are the limits. These are the limits. And second is the rho. What is rho? So rho is given at any point x, y, z. The density is equal to sum of squared distances. So if x, y, z be a point, then sum of squared distances means if x, y, z be any point, then its distance from x-axis is x, distance from y-axis is y, and distance from z-axis is z. So rho is equal to x square plus y square plus z square. This is our density. So we just need to put this density and the limits. So this becomes 0 to 1, 0 to 1 minus x, and 0 to 1 minus x minus y, x square plus y square plus z square dx dy dz. Again we will integrate the interior one integral, means z integral first. So let us take I1 is equal to 0 to 1 minus x minus y, x square plus y square plus z square dz, and this is equal to x square plus y square z plus 1 by 3 z cube, and the overall limit applies to 0, 1 minus x minus y. If you put these limits, you will get x square plus y square 1 minus x minus y plus 1 by 3 1 minus x minus y whole cube. And just simplify it further, because in next stage we will integrate with respect to y. So take x square 1 minus x minus x square y. I am simplifying this first term has no y, second term has first power of y. So x square 1 minus x minus x square y, and then y square minus plus y square 1 minus x. This term has second power of y, and finally minus y cube plus 1 by 3 1 minus x minus y whole cube. This is I2, and now we will integrate I2 with respect to y. So I1, let I1 is equal to, let I2 is equal to 0 to 1 minus x, 1 minus x, this is y integral, and I1 dy. Now we will integrate this with respect to y, as we have seen in the integral. So I is this expression. So just I am writing and you can see that in first term there is no y. So a y will come after integration. This will become y square by 2, y to the power 4 by 4, and this similarly this you can integrate this 1 minus x minus y, this 1 minus x minus y to the power whole 4 divided by minus 4, because y has coefficient minus 1. So this way we can integrate this. So we have I2 is equal to I2 is equal to x square 1 minus x y minus 1 by 2 x square y square plus 1 minus x 1 by 3 y cube minus 1 by 4 y to the power 4, and finally 1 by 3 minus 1 by 4, because coefficient of y is minus 1, 1 minus x minus y to the power 4, and the whole expression has the limit 0 to 1 minus x. So now you just need to put the upper limit, because at lower limit y you will put all the upper and lower limit. At upper limit the whole expression that you will obtain, and at the lower limit this I am indicating, at the lower limit this will become 0, this will become 0, this will become 0, this will become 0, but this term will not become 0. This will become 0 at upper limit. So this will become 0 at upper limit and evaluate at the lower limit. When you put y is equal to 1 minus x, this will become 0. So just put the limits and simplify. So you will get 1 by 6, 1 minus x to the power 4 plus 1 by 2 x square, 1 minus x whole square. This is I2, and finally our mass is 0 to 1 I2 dx. We have integrated one by one. So for internal integral, z integral, then middle integral means y integral, and then this is final integral. So I2 dx. So just put 0 to 1, 1 by 6, 1 minus x to the power 4 plus 1 by 2 x square, 1 minus x whole square. This with respect to x, and I hope we have done a lot of integration, so you can integrate it very easily. And after integration, this x integral, if you are unable to integrate directly, just open this in fourth power, open this and open. If after opening all the terms, you can integrate easily. So after you integrate and put the limit, the answer comes 1 by 20. So mass of the prism that we considered with a is equal to b is equal to c is equal to 1 is 1 by 20. So this is how we calculate volume and mass. Very necessary step and very important step that almost I think you have noticed is found the shape. Means if you can draw the shape and then you can find the limits, then everything is done. Once you draw the shape and find the limits, you have just to integrate. So you can integrate. Integration we have already discussed in multiple lectures. So keep on keep connected with me, and in the next lecture, I think in the next lecture I will continue this series. I will continue this series. In fact, I have decided to continue with the multiple integrals and using the substitution of variables. I will consider three type of substitutions. One, Cartesian to cylindrical polar coordinate, one Cartesian to spherical polar coordinate, and one Cartesian to any other orthogonal system and other coordinate. So these transformation will give you better and much idea of how we perform multiple integrals. And so you stay connected and watch, wait for the next video, next lecture. Thank you.